Okay, next I want to talk about sigma notation. Sigma notation. And this is again just another review. So if I were to have something like this, sum from n equals 1 to 6 of 2n plus 1. Well, what does this mean? What this means is I'm going to start at 1 here. My n will be equal to 1. I'm just going to plug that in. 2 times 1 plus 1. Then I'm going to increment. So now it was a 1, now it's a 2. So I'm going to plug that in. I'm going to plug in 2. And I'm going to increment again. I'm going to plug in 3. And I'm just going to keep doing this. You'll see. I'm just going to keep doing this until I hit 6. Plus, so now that I've hit 6, that's when I know I'm going to stop. So 2 times 6 plus 1, and that's it. So this is just a nice notation for this guy, and this is 3 plus 5 plus 7 plus 9 plus 11 plus 13. This is just a nice compact way to write out this sum here, okay? These two are the same. It's just that this is a much nicer notation. Let's do another example here. If I were to give you something like this, for instance, n equals 1 to 4 of n squared, well, that's just 1 squared plus 2 squared plus 3 squared plus 4 squared, okay? So what's happening here is I just start at 1, I plug in 1 here, that's 1 squared. Increment, that's 2, so 2 squared. Increment again, that's 3 squared. And then finally, since 4 is my upper limit, I just plug in 4 squared, and that's how I know that I'm finished with this sum. Okay, fine. But let's say I gave you something different. Let's say I wanted to go in the reverse direction. Excuse me. What if I told you, write as a sum in summation notation. So use sigma, and let me say sigma notation. That's what I was trying to do here. Sigma notation. Sigma notation. So here's the sequence. 1 plus 4 plus 7 plus blah 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 up to 25. Okay, well, this is, hopefully it's clear, maybe I should add another element. This is, hopefully it's clear, an arithmetic sequence. I'm just adding 3 each time. Okay, so the nth term here is, well, it'll be given by this formula, we know. So a sub n will be equal to 1 plus the common difference is 3 times n minus 1. Okay, fine. So that means that I'm taking a sum from n equals 1 to of 1 plus 3 times n minus 1. But where am I going to end? I want to end when this guy is 25. So I'm going to figure out what is my n here. What am I going to end on? 25 is equal to a sub 1, which is 1, plus 3 times n minus 1. I'm going to figure out what n here is. So this is 24 equals 3 times n minus 1. I'm going to divide by 3 on both sides, so that's 8 equals n minus 1. And that tells me n is equal to 9. So that means that this is the first term, second term, third term, fourth term, and that means that this is the 9th term. Okay? So if I were to, just to do a sanity check, if I were to plug in these numbers, first, if the first number is 1 here and I plug that in, I get 1 plus 3 times 0, which is 1, plus 1 plus 3 times 1 plus 3 times 1, which is 4. And then I'm going to increment again. Now my n is equal to 3. 1 plus 3 times 2, which is 7. Okay, looks good. Let's just keep going until we hit 9. So when I plug in 9 here, I get 1 plus 3 times 8. 3 times 8 is 24, and then plus 1 is 25. So that checks out. So we did the problem correctly. Okay, so this would be our answer. I wrote this, so I took this sum and I wrote it in sigma notation. Let's do another example. Write in sigma notation. Let me just come up with some interesting numbers here. Let's say I gave you this, excuse me, this thing, 2 plus 4 plus 8 plus 16 plus, plus 32. Write this in sigma notation. Okay, well, I know that, so this is the first term, second term, third term, fourth term, and fifth term. So I know what my limits are. I'm going to be going from n equals 1. You can use I, you can use n. Most people use I, but I'll use n. From n equals 1 to 5 of, well, what is the general term here? It's not an arithmetic sequence, it's a geometric sequence, right? The general term here, a sub n is equal to, well, a sub 1 is 2 times, and I'm multiplying by 2 to the n minus 1. Oh, but that's just, if you were to simplify this, remember your laws of exponents. This is 2 to the 1 times 2 to the n minus 1. That's just 2 to the n. So that means that the nth term here will be given as 2 to the n. So this sum, a nice tidy way to write this sum is n equals 1 to 5 of 2 to the n, all right? And so if you were to expand this out, start at n equals 1. This is 2 to the 1 plus 2 squared plus 2 cubed plus 2 to the 4th plus 2 to the 5th. Let's evaluate all of those. That's 2 plus 4 plus 8 plus 16 plus 32. That works out, so that's fine. So this would be our answer. This is how, so this was just a quick review on sigma notation and how to convert things into sigma notation. Now let's do one more example of an arithmetic sequence, and I think that'll be sufficient. So let me go here. Okay, so consider this. Write in sigma notation. I want you to do 30 plus 30 plus 20 plus 10 plus 0 plus minus 10 plus all the way down to negative 150. Okay? Let's figure out how should we go about this. Well, I want to start summing. I'll probably start summing at 1. This is an arithmetic sequence, so let's actually figure out what is the general term of this arithmetic sequence. General term, a sub n, is, let's see, my difference is minus 10. Excuse me, I apologize for my hoarse voice again. My difference is minus 10, so I start at 30 plus minus 10 times n minus 1, okay? That's the general term. Well, I know that this is the, let me erase this here. I know that this is the first term. I know this is the second term, the third term, fourth term, fifth term. But what term is this? Well, to figure that out, I just need to plug it into a sub n here, and it'll tell me what this is the nth term. What is my n? So minus 150 is equal to 30 plus minus 10 times n minus 1. I'm going to subtract 30 on both sides. I get minus 180 equals minus 10 times n minus 1. I'll divide by minus 10 on both sides. So this gets me 18 equals n minus 1. And that tells me that n equals 19. N equals to 19. Good. So n is equal to 19. That means that my sum is going to go from I equals 1 to 19 of, and what's the general term of this sequence? This guy. So of 30 plus minus 10 times n minus 1. And of course you can simplify this, you can distribute out the minus 10, but I don't really care. If you left it like this on the exam, I'd give you full marks. All right. By the way, the sigma notation gives us a nice way to rewrite our notion of a partial sum. So a partial sum, the nth partial sum, I should say, the nth partial sum of a sequence. So let's say you have this sequence a sub k is given by S sub n is just the sum from I equals 1 to n of a sub I. So that's not something you have to memorize, but what this is saying is that the nth partial sum is you add up a1 plus a2 plus a3 plus a4 up to a sub n, and that's the nth partial sum. So this is a nice, clean way to write that notion. So that's why sigma notation is so helpful, that and many other reasons. Okay, so we'll see some more utility in this. We'll learn how to re-index sequences, like let's say, here I've been starting at 1 for pretty much all of them, but let's say I wanted to start at 3. How can I do that? So we'll learn that next.